Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guides. The first one we're going to do, study guide A, has to do with graphing and solving inequalities. So let's go ahead. Here are the examples just to make sure that we're on the same page with everything. When you have an inequality, that means that there is a range of possible solutions, not just one single answer. So if we said X, our solution, is any number greater than 6, and it could be 7, could be 8, could be 9, could be 100 million, could be anything that's greater all the way up to positive infinity for solutions. When it says greater than, we are going to circle the 6. That's our boundary number, but we're not going to shade in the 6 simply because it says X has to be greater than 6 to be a solution. It can't be equal to. If it had the equal to sign underneath there, we would include our boundary number as a part of our solution by shading the boundary number in. So this one, X is any number that's less than or equal to -1. So find where -1 is on the number line, and everything to the left of it is less than that. We shaded in the -1 to tell us that -1 was one of the solutions. This is an example 3 of a compound inequality where you actually have a range of answers that has a lower limit and an upper limit. So the lower limit is -1, and it turns out -1 is one of the solutions because y could be greater than or equal to the -1. And I say that because the y is on the right side, but this reading from left to right literally is -1 is less than or equal to y, and y in turn is less than 6. So 6 is the upper boundary, but is not a solution. Everything in between the -1 and the 6 are solutions, including the -1. So with that in mind, how do we go about solving these problems? What did I do here? Oh, that's a bit of a mess. I don't really like this one at all. X is not equal to 1 is implying that anything other than 1 would be an answer. So you never see those. That's why I did this. Let me just do this one better and say, you do not exist as a problem. We don't like you at all. There you go. We can just cover that one up. But let's focus on the rest of them because the other ones are more important for us to understand. So here you just got an inequality. M is less than 2, so you circle the 2 and shade everything to the left. Here, X is less than or equal to -1, so we circle the -1 and we shade everything that's less than -1, including the -1 gets shaded in, so we're going to put that into the circle. Okay, so take a look at those. If there's any questions about any of those, please jump on to the Meet. I'm going over this in class as we speak. Hopefully you are doing this as the first thing as a part of your class. If you are viewing this later, then you maybe just email me and ask me to go over a problem, and I can work that out for you. One last thing. Notice how in all of these instances, how the variable is listed first. If you get in the habit of always list your variable first or on the left-hand side, then the direction that your inequality symbol is going is going to match the direction that you shade in the graph. That always works out. And then if you've got like a compound inequality such as this, then you know that your variable is in between those quantities, so you would shade everything in between those quantities, right? And there, and in there. All right, looking at the backside problems, here are some more. Okay, so you solve these problems the same way that you would solve any kind of equation, where x plus 3 gives you -1. So if you take away the 3 from each side, remove balanced sets, you get x all by itself is greater than whatever -1 plus -3 is. So you just solve these the same way that you do for equations. And once you solve it, then the number here becomes your boundary number that you circle on your graph, and then you decide whether it's shaded in or left open, right? This one's going to be left open, but these two have the less than or equal to, greater than or equal to, so you shade those in. And then if you've got your variable on the left, that's going to tell you which direction to shade in. That's going to tell you which direction to shade in. Okay, so same thing for this. Go ahead and check the answers, and if you have any questions on any of this, please contact me and let me work it out for you. Now, moving on to study guide B. This one is going to focus on solving the equations. And, all right, much better. I accidentally deleted them. All right, so working out problems 1 and 2. Number 1, you got 2x's plus 3 has to be equal to 25. So we'll take away 3 from each side, then divide by 2. That means that each one of those has to be equal to 11, and we can check it. 11 plus 11 is 22. And 22 plus 3 does give us 25, so we know we've got that answer correct. Here you got 2x's plus 4 is equal to x plus 16. So let's take away an x from each side, right? Get rid of this guy here and this guy there, leaving you with x plus 4 is equal to 16. And then take away the 4 from each side. This is going to give you the 12, so x is equal to 12. And we can prove it. If x is equal to 12, then 12 plus 4 is 28. And 12 plus 16 is also 28. All right, take a look at our answers here. See if you understand the basics. I'm not going to go over every one of them. I will briefly talk about 5 and 6. 5 is kind of getting you ready for a geometry rule that says that when you've got two angles that are supplementary to each other, meaning that when you put both of these angles right next to each other, they end up forming a straight line. What is going on? Why am I getting a little circle-y circle thing? I don't like that. Stop it. Okay, back to where we were. Stop it. There we go. Okay, so this angle plus this angle together makes a straight line, so that means they must add up to 180 degrees. So that means that x plus 122 is equal to 80, so I want to know what x was before I added the 122 on. So I'm going to take 180 minus 122, and that's how I get that this angle here is 58 degrees. And then I'm not sure when we first start talking about the sum of the angles inside of a triangle always add up to 180 degrees, but I do know that in 8th grade, we're going to focus on these concepts a bit in more depth, and we see that x plus 40 has to equal 180 because of triangle sum theorem. And then you've got your 2x's. So I want to know what the 2x's were equal to before I added the 40 in. So they must have been equal to 140 because 140 plus 40 is 180. So take this, 2 times something equals 140. You are correct if you said 2 times 70 is 140. So that means that each one of these angles must be 70-degree angles. And then we've got some 5D process work going on here. Go ahead and look through the answers. It's pretty straightforward. We've been working on this for a while. Describe and define your variables, set up the equation, solve the equation, then double check to make sure that your answers meet the definitions. It says Josephina is 5 years older than Cameron and the sum of their ages is 31. So we need 2 ages whose sum is 31, and they are 5 apart. And so 18 and 13 are the correct numbers. Now we just have to assign them to the correct person. Since Josephina is 5 years older than Cameron, she must be the one who's 18 and Cameron is 13. Marta, she has a jump rope. It's 25 inches shorter than 1.5 times the length of Tilbert's rope. So if we make Tilbert's rope the x, then hers is 1.5 times that minus the 25, right? Because it's 25 less or 25 shorter then. So then when we combine like terms, you got your 1.5x plus your x is 2.5x minus 25 is 221. And I'm really sorry, but you know what? You're allowed to use calculators. So this becomes a lot easier. It really doesn't make any difference if you get whole numbers or integers or rational decimal numbers. When you're using your calculator doesn't care. So just set everything up and work through the process and let the calculator do the heavy work for you. Problem 9, problem 10, go ahead and take a look at those. And if you have any further questions about those, please contact me. Otherwise, we are ready to move on to a chapter test. Okay? Take care. I'll talk to you later. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.